we should start. First, I think we'll introduce ourselves. My name is Artem. I'm working in IT for 12 years approximately. Mostly been working with Siebel, around Siebel infrastructure. I've been doing OpenUI. I also been a Salesforce developer for a while. And recently, a couple years ago, I've switched to the software engineering web development. And I worked with in the back end and front end and with the CI, CD. And then last year, I started working more with Siebel UX. So I have a year of Siebel UX experience. And Oleg?
I'm a Siebel developer. I have more than 13 years of Siebel experience, including also 5 years of OpenUI experience. I'm certified top OpenUI expert from the Siebel Hub and also Oracle certified Siebel 8 consultant.
Hi, my name is Andres. I'm software engineer at the PORT RIGA. I have around 10 years of experience as full stack developer, but lately I'm working on front end. And mainly I'm focused on reactivity ecosystem.
Okay, great. Now we'll switch to presentation. So here we go. Introduction. So we have 4 models. Start with introductions. So we already explained who we are. The agenda that we're choosing for today is we'll try to go through the front-end technologies first, the landscape views. We won't be able to deep dive into that. Then we'll just get some important topics from modern front-end technologies and try to elaborate on them. And then we will choose some of the setup, more or less full, that we're using here in PORT RIGA in our project. And we try to show the architecture on integration with Siebel, like how to embed this application in Siebel and what are the building blocks for the application and for the Siebel part as well. And then we also show a couple examples. After each of that models, we'll have the Q&A session. In case you have questions, you can just write it in the chat during the presentation or just prepare them and ask after each model. We start with the modern front-end technologies. There will be 2 main sections. So one is related to Frontend Frameworks because it unifies a lot of technologies for the modern development. And the other is for the building systems, which also exists for a while currently. All of this is a JavaScript, and the JavaScript world has rapidly evolved for the last 10 years. Things are changing all the time. Many of the technologies we used some time ago already deprecated and became ineffective and replaced with some other technologies. In general, if we want to improve our development experience, efficiency, the code quality, we need to start looking at what's happening currently in the market. There are many things, so we focused on the 2 main areas, is the front-end frameworks and build tools, as I said. There are many other smaller things. We won't be able to scratch them even today. Even behind that, so there are many front-end frameworks. There are many approaches to the building application, but we'll try to give a landscape view on that. What is the benefit of the front-end frameworks comparing to the classical approach, the JavaScript programming? There are many things. The most important ones here are the component-based design, which basically means that you can split your application to the several building blocks and organize the code. And also this approach gives you an advantage of reusing these components, and you also can reuse the third-party components, which are vastly available on the community. The second thing is there are some profound approach technologies how you can manipulate the document object model. There is, in particular, we have this data binding, two-way data binding, and a thing called the virtual DOM, which optimize the work, the updates to the DOM. Another thing it's important in front-end frameworks, it's build system. Most of frameworks need a build system. It's not a rule, but the build systems are important for the big applications. In the next slides, we'll go a bit in details about some of these advantages. The code that we write in the front-end frameworks basically is a pseudocode. It's not executed directly in the browser in most of cases. So by using the different languages and techniques, writing pseudocode gives us a lot of different opportunities. In particular, we look at the Vue.js, React, and Angular. There are tons of different frameworks, but those 3 are the biggest. They have big community, which is important for evolving the frameworks and supporting it. And these 3 are quite noticeable on the market. We don't pay so much attention to the Angular here currently. One of the reasons because it's quite a heavy learning curve. So if we want to quickly jump into using these frameworks, probably Angular is not the best. But in any case, we're going to look at the Vue.js and React. React appeared a little earlier than the Vue.js, but they quite comparable. There are no conceptual differences. React probably is a bit more popular, maybe since it appears earlier than the Vue.js. But Vue.js is showing the tremendous growth during the 2017, 2018. We try to spot a couple of minor differences. If you're curious what differs between Vue.js and React, it's not a rule, but we think that React is more low level, so it provides the flexibility, and its ecosystem also is larger. So if you search for the libraries, third-party libraries to work, maybe React has a bit more choice than Vue.js. Vue.js in turn has a very friendly learning curve. You basically can start developing it really fast. If you have the JavaScript experience, I mean, you can do that like during the day. Also, since it's a bit more higher level than React, it makes the code more compact and the framework more intuitive to use. We think here this is probably the best start for the Siebel developer who haven't used the framework before. If we're talking about the advantages of the framework, first is it's a component-based design. So components are reusable building blocks. You can split your code into different components by layout, for example. So you have like header, sidebar, content area. These components in turn can have child components, and thus you get tree structure of components, so your code is structured. Also, you might want to use components for your usability. So if you have buttons, controls icons, or any other thing that you can imagine that is a small piece of your code or design system, you can also use the component and you reuse it in several places. If we look inside the component, it has a template, it has logic, can receive the input properties and can emit events. Sometimes the styles are also included in the component. This kind of approach is, if you compare it to the model view controller architecture, where the view is separated, view logic is separated, and the controller logic and the data layer are separated. Here, all these pieces of logic can be united in one place, and thus you can create an encapsulated piece of your application that basically covers everything from the style to logic and to the template. Each component can be stored in a separate file, which also you can benefit on structuring the codes. If we look in details into the templates, the template is HTML-like structure. The point is that if you want to use a child component, so a component from the third-party library, it will look exactly the same in the structure. And in this example, you can see that you have 3 buttons, and the first button is just HTML. The second button is custom components in your application, and it's defined in a separate file. And the third one is a third-party library that we use for already UI components. In this case, it's also the button. You can pass the properties to the custom components. So the second and third buttons are components, and the first one is HTML element. In the second button, we have the custom property defined inside the component, and we can communicate to it. The third, it's predefined, so we can go to documentation of the UI library and see that it has the properties, in that case, flat or round and color. And by providing these properties, we can control the state of the component, how it looks and how it behaves. The click event, in the first case, is just a standard HTML event. In the second case, it's a click event that is defined inside the component, and it's triggered whenever the component logic decides. And in the third case, it's also defined inside the component, but it's done by the third-party library, also whenever it is needed. External components are easy to use, as you have seen on the previous slide. It's quite easy to use the components from the external libraries. Like, it's a recommended way to import the third-party libraries with Node.js, in opposed to the CDN import, because using Node.js, you can integrate it into your build. So basically, it's really easier to manage the application and these components if it is imported through the Node.js. Most JavaScript libraries are available in the NPM repository and the npmjs.com. You could just find the name of the library, and then you can import it using the Node.js into your project. And we also have stated a couple of the libraries that we are currently using in our projects. If we use a Vue.js framework, it's Vue-defined Quasar for UI components. It's Material UI if we're using React. We also use like animations for transitions, this Animate CSS, and some date libraries. I'll try to show you, for example, the Quasar library. As you enter, you can see the Vue components here on the left, and you can see all the UI components that are provided by that library, like badges, for example, or avatars, Also, you have the different kind of controls, like text fields, the drop-down fields, the multi-select fields, and so on. It contains most of the components that you need to build your application. The second advantage of the front-end framework is the thing called two-way data binding. Sometimes it also refers as reactivity. I was trying to snap here the piece of code to demonstrate this approach. It's basically an alternative approach to the DOM injections or jQuery, because jQuery is a conditional data binding, and here we have like sort of declarative data binding approach. This is the Vue component. On the mounted is a function that is executed when the application is started and the component is rendered. And here we define the variable called username. When you define it here in that place, it became reactive. When the application starts, we give it some default value here. And in the template and layout on the top, you can see that this variable is used to greet you, like just in the text tag. And also there is an input where you can input the username. As you use the same variable here in all these 4 places, as soon as you change it in one of the places, it is automatically changed in the other place in the layout. So basically, if we enter the username here, then it will be automatically displayed in the text above. Or if we change it to some other place, then it also will be changed in everywhere in the template. Here, we try to show the same example using the jQuery. We also give like initial value. And then, as you see, we need to do a jQuery update in every DOM element where this variable is used. So basically, if we use that in 10 places, we would have like 10 jQuery updates here. And also we have to react on the change as well. We're here updating only in one place, but in case we use that in several places, there will be more jQuery updates. Here's another example how we can use this two-way data binding. We can declare this reactive variable that controls if we open the dialog with the user. As you can see here, it's assigned to the button click. So when we click the button, dialog variables change to true, and then that automatically triggers the opening of the dialog. The third thing that makes front-end framework fantastic is a build system. The build system can exist without a framework. This is just a library that transforms one type of code into another type of code. When it works with the front-end frameworks, there are many beneficial things that we can get from that. All of them works on Node.js, which is a JavaScript runtime environment. I think it's important to say that the JavaScript that runs in the Node.js is not the same JavaScript that runs in the browser. This language in that case is used for building the application inside the operating system using some of the libraries, but this is no relation to the browser. Build system is responsible for building, transforming, bundling the code. As a result of build, the code will be transformed to the static CSS JavaScript HTML that can be later hosted by the web server and you can use in the browser. What are the bonuses that we get if we start using the build system? There are many, it's only named a few. So at first, when you use that with the front-end framework, it transforms the framework pseudocode into CSS, JavaScript, and HTML. You can also use that to minify the code for production build, for example, because these minification plugins, they can decrease your code up to 20 times. It significantly improves the load of the application. You can also obfuscate the code, make it unreadable if you, for some reason, want to hide the code. Not to say for hiding the code, but it takes place also. If you want to support the old browsers, there are plugins for that. Of course, if you want to keep the separate production and development builds, which is the case almost always, because for production, you want the code be minified. You don't want any libraries that helps you do the developments. Probably you don't need the source map, which lets you debug the application, so it makes the bundle smaller. Overall, the build system like Webpack supports tons of different plugins. It allows you to use different languages or the pseudocode languages like TypeScript, different styling libraries that probably are more profound than the CSS for now, and maybe the JavaScript templators like Pug. So all of that gives us a good instrument to improve your development efficiency and provide you more instruments to optimize the development experience and probably the quality of your code. We had an overview on the front-end technologies, and now we'll try to look in details into the specific set of technologies that we use here in our company and embed it into Siebel. Here you see more or less the key elements that we use in our toolset. There are many other smaller libraries, but they're not so significant for technical architecture overview. And it also may vary from the project to project, depending on the project needs. So Node.js is a must, of course, for building application. Yarn or NPM we use for package management to work with the third-party libraries. Building applications mostly with Webpack, and most of us also use the Visual Studio Code for coding. In case it's Vue.js, we use Vuex for global state management, Quasar or Beautify For external UI component library, and in case it's React, it's Redux and the Material UI external component library. We'll try to look at the big picture of the technical architecture. The application can be integrated into the physical renderer, to the applet or Vue. Later, we will use the Vue physical renderer, but it can be also done inside the applet physical renderer. So here you can see that the Siebel Vue on the left, there are applets configured, there is application on the right, and the Nexus bridge as an instance of the Nexus class is created for each applet, which allows us to manipulate the data inside these applets. Here is a bigger picture. We'll look what's inside our web application. So we can see that there's a Siebel backend on the bottom, and the Siebel web server is hosting the application build. We can require that in the custom physical renderer or using the Siebel manifest, or we can use the required JS as well. I will explain these differences in the next slide. As we're building application inside the Siebel Vue, we have the Vue presentation model, and for each applet we also have these presentation models. Inside our application we have Nexus class instances for each applet, the global state that is communicating to these instances. So global state is basically a block inside the application that is managing the global variables, and as well it is communicated with external sources to get the data or to modify the data or to store them. In the middle there is a component structure. Each component in this structure can access the global state, like require the data, ask for the data, or ask for modify the data or delete it. As you see also, one of the components here is red, and it's a component from external library. And the blue ones are just the custom components that we're using for our application. As you can see, as all the communication with Siebel is defined in the global state, we can easily replace the functions in the global state that work with data and make it work with some other source, not Siebel, like with mock data or with some other backends. When you're embedding your application, in order for it to work, you need to follow these few steps. So at first, probably you want to hide Vue and applets that Siebel has rendered. This can be done by CSS, for example, or in the Siebel web template. Then we need to load the application from the web server, add the tag in document object model that will be hosting the application. Then we can run the framework instance that will mount the application on this tag that we've created in the previous step. We also need to initialize the Nexus class for each applet and do the initial load of the data into the global state. The order of these steps is not necessary in the way that you see in the slide. Depending on the specifics of the applications, it might be different. And also some of that can run in parallel. So for example, you can create object instance and loading the data, initializing Nexus in parallel to optimize the loading time. There are options on how you can load the app. This one is the standard. You can use the manifest, assign it to the view where you want your application, and then it will be loaded when you enter this view. The other option is you can use the required JS. It's inside Siebel. It has access to the Siebel web server applications, and you can just require it when you need it. So you might have some kind of logic that decides if you want to load the application or not. If your embedding application is a direct child of the SW view, it will remain the DOM even after you leave the view. This means that your application does not disappear, and you can hide it, or the next time you enter the view, you won't wait until it's loaded, or you can also have one application for many views in that case, like we have in our Midnight UI. The only thing you would need to do is initialize the Nexus class and reload the data. And it's not the heaviest from performance perspective. The heaviest is creating the framework object instance and mounting the application to the DOM. Here comes example. This is the Vue physical renderer that we're using for React applications. As you can see, the application is required here on the top. So this is like React app static JS main.js is the custom application. So it is required there. And then in the show UI method, we are hiding the Siebel views, adding the DOM element, and then we're running the mount component function, the method that is provided by the custom application that we have imported. After that application is mounted on the tag, Siebel is hidden, and you will see the application. When you're leaving the view, one way or another, in the end life event, you're just unloading the application and mounting it from the DOM. Now, Olex will tell us about Nexus.
So Nexus is a JavaScript library. Right now, it doesn't have any dependencies. It's relatively small, written in ECMAScript 6. Its size only about 48 kilobytes, and when compiled for Internet Explorer 11, the size is only about 64 kilobytes. So if your modern organization would use for modern browsers, so you can consider, so it might be a good idea to compile your own version of the Nexus for a modern browser, and it's going to be smaller and faster. So Nexus extends the OpenUI by wrapping the Siebel applet presentation model, and the main intention is simplify Siebel API and hide some conflicts inside the Nexus code. It's mainly about format conversion and internalization, and also working with data in POP applets. It was already stated, I think, but actually it makes sense to mention what all Siebel configuration remains effective. So basically every code is configured in the Siebel tools, and in the Siebel application it's still in place, so there is no any hacks or something like that. Nexus is used by web applications what implement custom PR, so internally we are calling it the bridge to the modern web applications. One of the options how Nexus could be loaded is using Siebel manifest, so it's the application manifest administration. So I open application, I navigate to application manifest administration, and if I check application common, platform independent, I have the Nexus model loaded here, so it's Untitled Help.js. When it's loaded, the class is stored injected in the global scope, and it allows us to some experiments to allow us to create the instance of the Nexus just using Chrome Developer Console. It's quite helpful before writing any code to try something. When I create the instance of a Nexus, for example, I can check what controls are available. There are different methods what could return the controls and the information about controls and different data, for example, these controls. So I create the instance for the applet in the top. If I would like to use the data in all applets, so basically I have to create 3 instances of the Nexus. I'm not going to do it right now, but this is how it works, how Artyom's mentioned. For each applet, we have to create an instance of Nexus. I can see what I have 4 list columns. It's inactive name type CD and usage type CD. It's exactly the name as specified in the Siebel tools. If I expand the object, it contains some additional information. So it's like mainly attributes. The main attributes is field name, its label. So for this language is going to be translated to the local language. If it's lows, it contains available low value. If it's static low, for static low, it contains available values, max size, and UI type. Having knowledge about controls, I can proceed to something like with data manipulation, create a new record. So basically, that was the short example how Nexus could be used from the dev console. And if you check the GitLab wiki, you can find all methods, what Nexus exposes, description of these methods, signature, and everything, what you need to develop the application with Nexus. When we have the instance of Nexus, it allows us to manipulate Siebel data in safe way. It means all Siebel configuration is reused and all OpenUI behavior is the same. There is no risk of data corruption, something like that. We can define the 4 types of Nexus methods. The first is for data state retrieval. For example, I demonstrated this get controls method, but it's also more advanced method what returns the data and the information about logs and everything is described in the GitLab wiki. Data navigation methods, it's like next record and previous record, next record set, data manipulations, set control value, write record, and also query methods. All methods is described in the GitLab wiki. Sometimes application makes some changes, makes some modification, what updates the state of the business component. For example, when the immediate post change field is updated, some other fields could be updated, or maybe some fields could become read-only or editable. And the application needs to get, sometimes from time to time, need to get the updates in the presentation state model. And there are 2 typical approaches what we are using for that. It's old school, when web application decides itself when to get the presentation model state. For example, after each operation, what could change the state, it retrieves the new state. And in other options, it's easier to implement, it's safer, and it requires less coding. It's using publish-subscribe pattern. So application could subscribe to be notified about changes, providing the functions, what is going to be invoked when a state was changed. Currently, Nexus is located on our internal GitLab. On the GitLab, we have already mentioned wiki. It contains all information about Nexus, including installation procedure and how to install the quick start examples, and also other tips and describes the classes and its methods. We have also issues, the right place to suggest something or ask for improvements or feature requests, and also report the defects. To report the defect, please use the bug reporting template, what contains and provide all needed information, including Siebel version, Nexus version, and so on. So Nexus could be found in packages Nexus folder. We have source folder, and the main class is exposed as Nexus, and also what we use it with our experiment, there is made injection in the global scope. And there is a dist folder, it contains the compiled version for Internet Explorer 11. You can compile if you need and if you want to compile it for modern browsers. So it's going to work for all browsers actually, but if you want to make a smaller compilation, you can compile it just targeting some Chrome version of Firefox. Nexus already provides the needed methods for building a web application, and we are improving it, and currently it's under the Oracle review. So basically the Oracle is checking the code, and it will let us know what functions we are allowed to use For example, if something is not documented, the Oracle probably will document something, and if some functions or methods are not allowed to be used by customers, we will try to re-implement our code to use only. So when basically the target is use only documented Siebel bookshelf functions. When Oracle review is completed, Nexus will be published as npm package. Also, it became publicly available on the GitHub.com under MIT license. We also need to define the scope of the support. It probably is going to be Internet Explorer 11, Edge, latest Chrome and Firefox versions. And Siebel probably only starting from Siebel 16. That's it.
I'll be quick so we'll have time to watch the examples as well. So I already started talking about the global state. Here we take Wix as example. The global state is used for Vue.js framework. The main reason why global state exists is because it stores the global variables, so they could be accessible from all the other components. The Wix itself is reactive. That means that it updates the component state as soon as the global state is changed. We'll look at that on the next slide. Then you can define the patterns for state manipulations. It also serializes the changes to the global state. You won't have like two changes happening at the same time. It's quite natural also not only for the variables but also to doing the API calls, as I told before. So it's good for storing the data from the applets, for example. The global state itself is not necessary, but it's recommended for the big applications. A couple words about this reactivity of the global state. Basically in this schema you can see that when one component updates the property in the global state will automatically trigger the change of the state in the other components which are subscribed to the state. It will change the state inside those components and also will re-render the part of the application that is responsible for that variable. Okay, so we're done with the architecture. The next is I'm going to explain you how the development and the build process is happening quite briefly. This is like a classical layout. You have Siebel dedicated client for a developer. You also need the Node.js environment. You would need your project. When you start it in development mode, it starts basically the development server, and Node.js is responsible for that. Here you're telling the build system that it should move the build into the dedicated client web server folder. You also can see that there is like ID, so you're developing, and as soon as you've done the change to the file and you save it, it will trigger the automatic compilation of the application, and it will automatically restart the browser for you as well. You just save file and you will see results right away in the browser. It doesn't recompile the whole application, it only recompiles the model that is responsible for a change. That's why it's called HMR hot model reload. What is missing here is like the Git repository, but for small projects we're probably not using that, but we use it here in our company as a rule. For production build it's easier. You can also use, for production build you can use the same environment that you use for development, but you're just running the build system in the production modes, which will create a different bundle, which is more optimized. And you can just manually copy it to Siebel server as we're doing now, but we can also introduce the continuous integration, continuous development provided by the GitLab, for example, that will automatically copy the compiled bundle from the Git into the Siebel server. Okay, so I'll show a demo on our Midnight UI application. We have several views for the Midnight application. We'll have a look at the Midnight Calc 360 view. I have set the IDE open here. Maybe what I want to do is add some kind of profound control into the application. In Quasar we have a thing called knob. Basically, depending on the value, it shows the progress and you can change it. So in order to do that, I want to look at the source. There are two knobs. So I'll try to copy the first one. One thing to notice, I'm not using a standard HTML here, I'm using a pack templater. That's why the HTML looks a bit different, but it's still HTML, it's just made for convenience of the development. So I actually have it already copied in the pack syntax. What we have here is this like third-party component, and it has a property called vModel. It's just used to pass the data into the component. So we need to define the variable, the progress variable. Okay, I already have it, and it's 20. Basically, that's it. We need to save. So we should see this knob with the progress value 20 in the line color. Yeah, we can see this progress. For some reason, this the number 20 is moved, but it's maybe a delayed issue. But the component is there, and if we try to click it, we can see the result. We can see that it's changing. If we are like integrating that as a control as part of this application that works with Siebel, all we just need to do is to bind this progress value to the Siebel control in applet. Okay, Andrei also have another example on React. We'll switch presentation to his computer. And this is the last demo.
This is our application. We have here two applets for account, form applet, and a list for contacts related to this account. We can switch between accounts. We can also see related contacts list also updated. And that's it. It's pretty simple. I will show how to create such application from the start. You need to open this project and go to README and follow simple step how to put this application into your Siebel client. For example, you need to create folder in Siebel client, and I will open my custom folder where is no such folder, so I will create it. You can do it from command line. You go to Siebel client, you create a folder for your project. When you need to copy a physical renderer, so you go to your project and copy physical renderer. You can see this folder now empty. Now I copy and I get here physical renderer. Third step is to create a link from your source code to application build. So you go again to your source code and create a link. Now you can see where is link to application bundle. So your Siebel client is configured and you can start development. You can open, for example, embedded console in code. It's same as command line, and you have basically two commands. For example, I can run jump start. It will compile application. And you can see what here will appear bundle. So it's compiled, and you see bundle. Now your application works. I will load it. Looks like working. And now I see how to make actual development. For example, you can open application main file, go to render method, and from the top of render method, you can add, for example, some div. I will write just test. Now, as I will save this file, application will be recompiled and reloaded in browser. So you can see it appears here. I will run back, save again, it should disappear. You can see here, test is disappeared. Now I will add to this application a new field. For example, for account type, you should go to forum and create a new field. For example, it will be the same select field for type, like you basically copy-paste this field and change its name and change handler. Here it's now nothing, we don't have values for this field, but also you can see I have TypeScript error. It means like my state doesn't contain this field, so I need to add it. I have this file for state, it's called initial state, and I add this field. I added this field to the state, so error disappears, and now I have this field, but it's still empty, but it should appear here, so it appears, but it's empty. I will create, for example, content for this field. Count type is here, we use Nexus instance, and we request options from static lab for this field. It's called type. So I saved, and actually we see all the options for this field. That's it.
Looks great. I think we're done. Probably Yuris wants to finalize because he wanted to say something.
Yeah, so basically, thanks everyone for coming. If you look at this group of people which was here today, there is a lot of Gemini people. We're going to work together on one of the projects in Finland, implementing this Nexus approach in Siebel OpenUI. Then there were some people from company Reply, then there are some Oracle people, Lizzie, of course, and people from MTS. I think with that, we will conclude our kind of series of the webinars for now. Oracle today sent the list of the upcoming Siebel Road Show events, and at least to those in Europe, so we'll be definitely attending. And Lizzie, I will talk to you, like, which one are you going to attend? Is it like Atlanta one or Toronto one? And then in the Siebel events, we will try to demonstrate the progress we are making with different customers using this approach. And of course, if you guys are having kind of good story, how you changed the Siebel OpenUI, how you extended Siebel OpenUI with the modern frameworks and this reusable component, it would be great to hear from you as well. But with that, I don't see, like, do we have some questions maybe? So my chat is gone somewhere. Well, not really. So basically, we will see each other in the fields. You can always reach out to us by writing an email. The address I will attach to the email after the webinar with the recordings to this presentation Artyom, Oleg, and Andrei made, and also with the slides. And then we'll keep in touch. So good luck with the Nexus 19, and let's keep improving Oracle OpenUI. Thank you. Bye-bye.
Bye.
Bye.